Example 2, in 2001, the mean rate of inmates on death row was 40.7 years, according to data by the U.S. Department of Justice. A sociologist wondered if the mean age has decreased since then. She randomly selects 32 inmates who have a mean age of 38.9 and a standard deviation of 9.6. Tests the claim at the alpha equals 0.05 level of significance. Step 1. What type of test is this, a mean or a proportion? It talks about the mean rate, so we're talking about a mean. Also, there's no percents in the problem. That's another clue that it's not a proportion. So what are our null and alternative hypotheses? In 2001, the mean rate was 40.7, and a sociologist wonders if the mean has decreased since then. So our null hypothesis is that the mean is 40.7, and our alternative is that the mean is less than 40.7. And we're given alpha equals 0.05. So now we go down to our sample data about the mean. We have 32 inmates, so that's our sample size. They had a mean age of 38.9, our sample mean, and a standard deviation of 9.6, our sample standard deviation. So now we go down to the new part. So we're going to use StatCrunch, and we have a t-stat for the mean, not the proportion stat. So now we're going to do t-stat, one sample with summary. These three boxes match exactly the three things from step 3, our sample mean, 38.9, our sample standard deviation, 9.6, and our sample size, 32. Now we want to choose hypothesis test and change the numbers to match what we have in step 2. It is a mean. It's equal to 40.7 for our null hypothesis. And we want to show that it's less. So when we compute, our test is repeated there. And we have our t-stat. That's our test statistic. And our p-value of 0.1485. So our test statistic was our t-stat, t equals negative 1.06, and our p-value, p equals 0.1485. Our p-value is greater than alpha. We do not reject the null hypothesis. And since we cannot reject the null, there's not sufficient evidence to make a conclusion that the mean age is less than before. Okay? Getting no comments? I'll go on to the next one. Example 3. A bank claims that the mean waiting time in line is less than 1.9 minutes. A random sample of 20 customers has a mean of 1.7 minutes with a standard deviation of 0.8 minute. If alpha is 0.05, test the bank's claim. So we have a mean test. The bank claims it's less than 1.9 minutes. So we're going to use 1.9 minutes in our claim and our same. And alpha is 0.05. And we fill out our sample mean of 1.7 minutes, sample standard deviation of 0.8 minute, and sample size of 20. Now we're going to pop on over to StatCrunch to do a mean test. So that's going to be a t-test. Let me just clear this and scroll first. Because in step 5, it tells us use a t-stat or a proportion stat. So it tells you which test to use. So we're going to do a t-stat, one sample with summary, and put in our data for this problem. 1.7, 0.8, 20. Our hypothesis test was equal to 1.9, and we were looking for less than. So we compute. And we get our test statistic. And our p-value. And we go back to our sheet. And our test statistic, we had t equals negative 1.11. And our p-value, p equals 0.1387. Again, p is greater than alpha, and we do not reject the null hypothesis. So there is not sufficient evidence to make a conclusion that the mean wait time is less than 1.9 minutes. Okay. Example 4. In example 4, we're told the mean